Hello, so welcome back to my live stream. We go live in few seconds. Oh, hello, I'm already live. I'll start in few seconds. Just making sure everything is set. All right, so welcome back to Excel Island live stream. My name is Abatan Sheriffdeen, as you already know, and welcome back to the live stream. If you're an existing subscriber, and welcome if you're a new subscriber. So basically, what I've been doing so far on this channel is I've been live streaming my learning journey, trying to upskill myself as a data analyst using the resources on the Datacamp platform. I'm currently a top rated plus freelancer on the Upwork platform, and I decided to upskill myself and be more relevant in the data space. As you know, technology keeps improving, new technology, new tools, new roles keep popping up. I'm trying to stay relevant in the data industry. So I'm currently on the data analyst in SQL career track. The goal is to upskill myself in Excel, Microsoft Excel, SQL on Power BI, Python. So I started with the data analyst in SQL career track, which the goal is to study all the resources on SQL on the Datacamp platform for the next 100 days. And I have been so consistent, and today is actually day 26. So I've had so many challenges. I've faced so many challenges also, like when I had a burnout when my gadgets developed for us, I had to take a break. So I've actually learned a lot in trying to learn technical skills like this within the next 100 days. And I will surely be making a video and sharing my experience about that also. So I'm currently on the data analyst in SQL career track. I'm 81% through the O resources in this career track. Also, I plan to start the Power BI data analyst in Power BI career track also after I must have finished the data analyst in SQL career track and build a lot of portfolios and a lot of practice. Get it now. And probably after I finish data analyst in SQL career track, while building portfolios, solving SQL queries, I'll probably be simultaneously starting the data analyst in Power BI career track also. So just to keep this habit of learning going. So if I go to data analyst in SQL career track, so I've actually completed, it contains 11 courses. So I have actually completed 9 courses rather. So I'm actually starting the 10th course on this live stream, which is understanding data visualization in SQL. I have no idea that is possible in SQL also. So that's the purpose of learning. You always learn something new, no matter how good you think you are. So I finished the data-driven decision making on yesterday's live stream. So I'm currently starting this understanding data visualization. So an introduction to data visualization with no coding involved. So that's cool. Probably we just do a lot of reading. Then we have data communication concept, which is the last course in this career track. Then I have to do my course projects, statement of accomplishments. So also, I think there is also the Datacamp certification here, which I can actually take right now. Probably I'll be taking it after the whole courses, just to focus on one thing at a time. So let's start this understanding data visualization with no coding involved. So I'll go back to my progress dashboard. So before I start this lesson right now, so as I said earlier, I am a top rated plus freelancer on the Upwork platform. So I've had major success on the platform, and that is due to the influence of a coach, someone who has actually guided me and put me through the roles and the do's, the don'ts, the ropes, and all I have to know about becoming a successful freelancer. Rather, you get it now. So his name is Ben Gadibi, and he currently has a course called the Freelance Client Magnet course. I'll leave a link to the course under the YouTube description to make sure to check it out. So you can also go on Twitter. Go on Twitter and check out on BengaDB. So this is him here. So you can check out BengaDB on Twitter. So he's a highly rated freelance coach. You can see a lot of his pin tweets. You see a lot of testimonials from last year, and it's currently compiling testimonials from this year also. So you want to get that course right now. I'll see you in the freelancing community. So let's start our learning today and learn something new. Understanding data visualization with no coding. So I guess this chapter also contains you can see 4 chapters. So this course also contains 4 chapters. Oh, sorry about that. So what I always love to do is to download the slide as I learn with the instructor. I'll just download the slide very quick and put on the slide, open the slide on my second screen. Just 38 slides. So I'm here. So let's start.
Hi, I'm Richie. In this course, you'll learn how to choose an appropriate plot to answer common questions about different data types. You'll also learn how to interpret common plot types like histograms, box plots, scatter plots, line plots, and bar plots. Finally, you'll learn about best practices for drawing plots and how to avoid pitfalls. Throughout this course, you'll see lots of data sets from many different fields. I want you to get a sense that data is everywhere and that drawing plots is a great way to make sense of it. There are 3 main ways of getting insight from a dataset. Firstly, you can calculate summary statistics. That includes measures of quantity like mean or median, and measures of variation like standard deviation. Secondly, you can run statistical models like linear regression and logistic regression to model relationships between variables. Thirdly, you can visualize data by drawing plots, like a scatter plot or a histogram. These 3 ways are often used together and have different benefits. In this course, we'll focus in on the third way. The Datasaurus Dozen is a collection of 13 data sets with names like Away and Bullseye. Each dataset has 2 variables, the X and Y coordinates. Variable is just statistics jargon for a column of data. If you calculate the mean of the X values in each dataset, you can see that it's more or less the same value. It's the same situation for the means of the Y coordinates. The value is the same in each dataset. Similarly, we can look at the variation of the X and Y values by calculating the standard deviation for each dataset. Variation describes how spread out values are. Each dataset has the same standard deviation for X and Y. Here's the scatter plot of each dataset, and even a quick glance shows what the calculations failed to. That is, each dataset is completely different. Until you physically look at the datasets, it's hard to tell that you have lines and circles and a star and a dinosaur. The datasets are artificial, but I hope this example has convinced you of the importance of plotting your datasets. Before diving deeper into plotting, it's important to acknowledge that there are different types of data. Choosing a type of plot depends on whether your variables are continuous or categorical. Continuous variables are numbers, such as heights, or temperatures, or revenues. You can do arithmetic on continuous variables, like adding 2 temperatures together. Categorical variables are things that can be classified and are usually written as text. They include eye color, which takes the categories blue, brown, and a few others. Other examples include country and industry, which have a longer list of categories. Finally, some things can be either continuous or categorical. Age is a number, so by default, it's a continuous variable. However, many surveys use age groups like 25 to 30. Those age groups are categories. Similarly, time is naturally a continuous variable, but if you have to produce a report on how prices change each month, you might want to think of the month of the year as a categorical variable. In this case, you have the freedom to treat the time as either continuous or categorical. It depends on the question you're trying to answer. It's time for your first set of exercises.
In this chapter is more of less coding, more theory. Motivating visualization. To get an insight from a data set, you can calculate summary statistics or run statistical models. But often, it is easier to draw a plot. In this exercise, you can see the price of the Bitcoin cryptocurrency from the start of 2016 to the start of 2020. Columns in the middle are filtered and sortable. Look at the Bitcoin prices on January 1st each year. Which year began with the highest Bitcoin price? Which year? January 1st, 2016, second, third, fourth, fifth, sixth, date, price in USD. January 1st of each year. So the year is from 2016 to 2020. 2016, 17, 18, 19, 20. I put 2016 there. 01, 434. 2016 is 434. Let's look at 2017. 99. 2017 is higher. 2018. Oh, 2019. I'm guessing it's 2020 then. 2020. 7188. But let's see 2017 again. 997. Oh, didn't get that. For 2018. 13. Oh, 2019. 3869. Low. 2016 is out of it. 2017 just less than $1,000. 2018 more than $1,000. 2019 $3,000. 2020 $7,000. Is 7,000 above $7,000. Is 30,000. I'm not looking at these numbers very well. I know it's 2018. This is 30,000. Perfect. Price plot probing. Often looking at a plot is quicker way to answer this question than pouring to data. And that's true. The plot is much more better than looking to numbers. That's not fair. It actually made me to look to numbers there. That is loading up. Okay, so it says continuous versus categorical variables. In order to choose an appropriate type of plot to draw, you need to be able to distinguish between continuous variables, roughly things you can do arithmetic on, and categorical variables, roughly things that can be classified. So mass, drag the item into the correct bucket. Mass of squares. That's funny. Province of town in Canada. Job titles of employee. Population of towns in Canada. Species of squirrels. What was the exam? Was the exam pass or failed? Categorical. Percentage of questions answered correctly. Salary of employees. Let's see that. That's pretty easy. That means we understand the difference between continuous variables and categorical variables. Let's talk about histograms. Okay.
Let's explore histograms. Histograms are a type of plot that takes one continuous variable as its input. It allows you to answer questions about the shape of that variable's distribution. For example, you might want to know the lowest and highest values, and which values are most common. Here's a dataset on the kings and queens of England, and more recently Britain. It stretches from the current monarch back in time to the first king of England, Athelstan. Let's take a look at the distribution of the ages when they ascended to the throne. The x-axis is the variable that we're interested in, the ages. These ages are grouped into bins, that is, intervals. In this case, the bins are 0 to 5 years, 5 to 10 years, and so on, up to 60 to 65 years. The y-axis is the count of monarchs who began ruling when they were in each age bin. For example, 4 monarchs began ruling when they were between 10 and 15 years old. Straight away, you can see that there have been no monarchs who started ruling when they were between the ages of 45 and 50. The appearance of a histogram is strongly influenced by the choice of bin width. This is the same histogram as before, but with the bin width changed from 5 years to 1 year. It's difficult to get much insight into the distribution because the counts are very noisy. Choosing a bin width that is too wide also causes problems. By changing the bin width to 25 years, you don't see any detail in the distribution, and again it's hard to get much insight. In general, it's difficult to know the best bin width before you draw the plot, so you'll need to experiment with several values. When interpreting histograms, the first thing to look at is the modality of the distribution. That is, how many peaks there are. A distribution with 1 peak is called unimodal, a distribution with 2 peaks is called bimodal, and so on. Here the distribution of ages is unimodal because there is 1 peak from 25 to 35 years. A second thing to look at is the skewness of the distribution. That's statistical jargon for whether or not it is symmetric. A left skewed distribution has outliers, that is, extreme values, on the left, and a right skewed distribution has outliers on the right. The outliers look a bit pointy, so I like to remember which way round these are by imagining that the outliers are a shish kebab skewer. In a left skewed distribution, the skewer points leftwards, and in a right skewed distribution, the skewer points rightwards. Here, the distribution is more or less symmetric. One more advanced thing you can look at is the kurtosis of the distribution, which affects the number of outliers. A mesokurtic distribution is something that looks like the bell curve from a normal distribution. A leptokurtic distribution has a narrow peak and lots of extreme values. Leptokurtic distributions are important in finance because weird stuff happens in stock markets more often than the normal distribution would predict. A platykurtic distribution has a broad peak and few extreme values. Here, the distribution of ages is slightly platykurtic. Time to draw some histograms.
Okay, interpreting histograms. Says there is a histogram of salaries for various jobs in Australia. Each row of the data set is the average salary for that job. So the counts are count of job. Tips. The left hand pen. First tip, the left hand pane of the exercise contains text and instruction is resizable. Okay. If the plot is too small to see clearly, making the pane wider will increase the plot size. Move your mouse in between the left hand pane and drag and drop portion of the exercise so a gray vertical bar appears. In Chrome, click and drag this bar to the right. In Firefox, click the bar, move your mouse right, and click again. To categorize this statement about the histogram as true or false, the most popular salary in the bucket is 580k. How do we know that? It's 400k. It's false though. Histogram is unimodal. So, false. Histogram is right skewed. We say it is right skewed. That's correct. The most popular salary bracket is 60k, or we could say that is above 60k count. Histogram is bimodal. It's not bimodal, that's false though. Histogram is left skewed. When I really want to, that's 560 to 580k. Here is a histogram of salaries for various jobs in Australia. Each row of the data set is the average salary of that job. So the count are counts of jobs. So this count are count of jobs. Average taxable income. Not unimodal. Most popular salary is 40k to 60k. 40k to 60k. Let's see that. Close to 40k here to 60k. We say it is bimodal. Say it is not bi, definitely uni. Aha, I know I'm missing something there. Correct. Adjusting beam width. But the appearance of a histogram is heavily influenced by the width of its beam. The intervals that determine where each bar lies on the x-axis. If the beams are too wide, we do not see enough detail in the shape of the distribution. So if the beams are too narrow, the distribution can be obscured by noise. It is very difficult to know the best beam width until you physically look at the plot. Let's draw a lot of histogram with a range of beam width until you find the one that helps you answer this question. So we need to play with the beam width here. Here you can see a histogram of agouti, a rodent, sightings from a camera trap on Barra, Colorado Island in Panama. So when an animal passed the camera, a photo was taken with a timestamp. So the histogram shows the distribution of the time of day when the agouti were most active. Which of these statements about the agouti activity is true? The agouti had a high level of activity from 4 a.m. to 12 p.m. Let's see. 4 a.m. My question is not answered here. I'm using 0.25 bin. There's not this too wide. Let me use, I can't be in the middle. It's not possible. No, let me use bin of 1. 4 a.m. This 4 a.m. Yeah. To 12. No. The activity were most active for a couple of hours after sunrise. Let me use the bin width of 2. Ooh. How about 4? That's too much. How about 8? 8 is too wide. It's between 4 and 1. Let me say the activity skewed a constant level of activity throughout sunlight hours. If I'm using 1, one is likely close. So the activity had a high level of activity from 4 a.m. This 4 a.m. here to 12 p.m. 12 p.m. The moderate activity from 12 p.m. to 8 p.m. This is close to the answer using a bin width of 1. But let's see. That's not correct. So this is not close to 8 a.m. I go with a bin width of 2. This, so the activity were most active for a couple of hours after sunrise. After sunrise, couple of hours, 6:30 a.m. to 8:30. You could say that. And before sunset, 4 p.m. to 6 p.m. That's close. Using that, that's close exactly. That is close. Well, interesting though. So the bin width is very tricky. Just have to play with it and find the one that makes sense. Oh, let's finish this chapter 1. Right?
Individual histograms are great, but there's a problem if you want to draw lots of them. Let's revisit the kings and queens dataset. Suppose we want to see the distribution of ages for each royal house. A naive solution might be to draw the same histogram, but using different colours for each house. Sadly, this is a horrible, muddled mess. In many cases, the only sensible way to draw lots of histograms is to draw them in their own panel. Here you can see 13 histograms, one for each house. This approach still has problems. It's quite easy to compare distributions for panels that are in the same column. You can see that monarchs from the Wessex family were typically much younger when they began ruling than those from the Windsor family, since you can look down the column and see that the Wessex distribution is to the left of Windsor's. By contrast, it's harder to compare distributions between panels that are in different columns. To compare the ages of monarchs in the rival York and Lancaster houses, you have to do a lot of looking back and forth and staring at numbers on the x-axis, which isn't ideal. You could align all the panels in a single column, but that often means running out of space. Here, the text on the plot is almost unreadable. Fortunately, box plots can solve our problems. Box plots split a continuous variable, like age, by a categorical variable, like royal house, and allow us to compare the resulting distributions in a space-efficient way. Here's a comparison of the histogram you saw before with a box plot. The line in the middle shows the median of the distribution. That is, half the monarchs started ruling before this age, and half after this age. The box in the box plot extends from the lower quartile to the upper quartile. The lower quartile is the point where 1/4 of the values are below it. That is, 1/4 of the monarchs started ruling before this age, and 3/4 after it. Likewise, the upper quartile is the age where 3/4 of the monarchs started ruling below this age. The difference between the upper quartile and the lower quartile is called the interquartile range. The horizontal lines, known as whiskers, have a more complicated definition. Each bar extends to 1.5 times the interquartile range, but then they are limited to reaching actual data points. The technical definition is shown on the slide, but in practice, you can think of the whiskers as extending far enough that anything outside of them is an extreme value. As mentioned before, the power of box plots is that you can compare many distributions at once. Here, the royal houses are ordered from oldest at the top to newest at the bottom. A trend is visible. Since the Plantagenets in the 14th century, the boxes gradually move right, showing that the ages when new monarchs ascended the throne have been increasing. Godwin and Blois appear as a single line because there was only one king from each house. The Anjou house only had 3 kings and forms a box with 1 whisker, not 2.
Notice that the box plot for the House of Denmark,
Godwin and Blois. Here, the royal houses are ordered from oldest at the top to newest at the bottom. A trend is visible. Since the Plantagenets in the 14th century, the boxes gradually move right, showing that the ages when new monarchs ascended the throne have been increasing. Godwin and Blois appear as a single line because there was only one king from each house. The Anjou house only had 3 kings and forms a box with 1 whisker, not 2.
notice that the box plot for the House of Denmark shows a point. Points are extreme values, that is, values that are outside the range of the whiskers. Denmark's rightmost outlier is Sweyn, who ascended at age 53, which was exceptionally high for the 11th century.
Let's draw some box plots.
Yeah, let's do some box plots. Oh. So here are the box plot of cigarette consumption per person in the US from 1985 to 1995. Alaska and Hawaii are not included. Each observation in the data set is the average number of packets of cigarettes smoked per person in one state in 1 year. Thus, each box plot represents the distribution of 48 data points because there are 48 US states included in the data set. Let's see. Categorize this statement about the box plot as true or false. As true or false. So the upper quartile number of packets of cigarettes smoked per capita decreased every year from 1985 to 1995. Does it decrease? Looking at the box plot, kind of hard to read at first. I doubt it decreased because you can see the outliers here at this edge here are wild. I see an outlier here, 1995, 1985, 1995. The median number of packets of cigarettes smoked per capita was below 100 from 1991. The median in 1991. This is the median here. Median below 100, that's true. 1991 below 100. So the interquartile range. Let's see the interquartile range. The interquartile range of the number of packets of cigarettes smoked per capita was smallest in 1992. The interquartile is the difference between the lower quartile and the upper quartile. So it says number of packets of cigarettes smoked per capita was smallest in 1992. Let's check 1992. You see the interquartile range is smallest here. Eh? The difference between the lower quartile and the upper quartile. You could just agree that it was small. I need to start doing some calculations here. If I say this is 105, 50 to 100, so the difference here is 10, 10, 50, 60, 70, 80, 90, 100. So the difference from here, so that is 80 or 90 minus 110. So 110 minus 90. So the lower quartile number of packets of cigarettes smoked per capita decreased every year from 1985 to 1995. Lower quartile. So let's see the lower quartile here. Lower quartile is here. It's increasing, no? Let's see. From 1985. The interquartile range of the number of packets of cigarettes smoked per capita decrease every year. The interquartile range of the number of packets of cigarettes smoked per capita decrease every year from 1985. Interquartile range. Do we see that decrease? In 1990, 3 states were considered to have extreme values in the number of packets of cigarettes smoked per capita income. In 1990, we can see a state here, extreme values. You can see 1, 2, 3. You say that's true or false, but only 2 states have extreme values. And one of them is not correct. Let me double check this. I have to double check now. But before that, let me double check one more time. So the median number, where is my diagram? The median number of packets of cigarettes smoked was below 100 from 1991. From 1991, yes. So the median was below 100 from 1991. In 1993, states were considered to have extreme values of cigarette smoke per capita. In 1990, you can see this one is low value. These are the 2 extreme values. Are they considering this number here as extreme also? The lower quartile number of packets of cigarettes per capita decreased every year from 1985. The lower quartile. This is the lower quartile here. Do we see it decrease from 1985? Is it decreasing or increasing? These lines are getting longer, so it decreased. So the lines here, so lower quartile here, they are getting longer. It is decreasing towards 1980, towards less than 50. That's correct. So the upper quartile number of packets of cigarettes smoked per capita decreased every year. The upper quartile here decreased, but the outliers were much. The interquartile range of number of packets of cigarettes smoked per capita decreased every year. The interquartile range. Interquartile is the difference between the lower quartile and the upper quartile. So is it decreasing from this year? We have to do some calculation there. Oh, that's cool. The interquartile range of number of packets of cigarettes smoked per capita was the smallest in 1992. Okay, that's interesting though. This is the final part of chapter 1 for ordering box plots. Let's finish this chapter. It says ordering box plots. How you order the box plots affect the kind of questions that are easy to answer. Here, you can see the US cigarettes consumption data set again. This time, each box plot represents the distribution of cigarettes consumption over time for a given US state. Thus, each box plot is formed from 11 data points representing 1985 to 1995. By default, the box plots are ordered alphabetically by state name. This makes it really easy to look up the details of a specific state, but difficult to answer questions about where the highest or lowest consumption can be found. So sorting the rows by the median cigarette consumption makes those questions easier to answer. Interquartile range measures the variation in the middle half of the population from the 25th percentile to the 75th percentile. That means that sorting by the interquartile range makes it easier to answer questions about how much variation there was among the typical population. So which statement is false? There's a lot of information to consume. Let's see. It says which statement is false. So the lower whiskers from Alabama is completely above 100 packs per capita per year. Let's see Alabama. I'm choosing Alabama. That will be easy to answer. The lower whisker. I go to Alabama from here. Alabama. Is Alabama here, the last one here? It said the lower whiskers for Alabama is completely above 100. Lower whisker, that's 2. North Carolina has the fourth highest median consumption. North Carolina. I see South Carolina here. Where is North Carolina? I see North Carolina is there. It says North Carolina has the 4th highest median consumption. Median. How do I know it has the 4th out of many boxes here? Come on. I filter it to the median per year. Let's see. Median. Then North Carolina. North Carolina is not even in my filtered results here. So it's a North Carolina has the what? The 4th highest median consumption. Oh, the median. This is the median. How do I know that? The 4th highest. The median is above 100 here. You can see 1, 2, 3, 4. That's true. The median is above the other ones here. You can see the North Carolina is the 4th highest. That's true. So New Hampshire has the 3rd widest interquarter range. Widest interquarter range. New Hampshire has the 3rd widest interquarter range. So let's see. Okay, this is it. Widest interquarter range. Ooh. The interquarter range is the difference between the lower quarter and the upper quarter. This is like in the middle. Let's say that is false. Oh, I didn't feel that. I didn't get that. This is the middle. Third, okay, as the 3rd widest. That is wrong though. I see why it is middle here, but Idaho has the 4th lowest median consumption. Median consumption. Idaho. Let's check Idaho. Has the 4th lowest median consumption. The median is the middle number here. I can see from here right now, if I just move my mouse a little bit up, none of them is having median like Idaho here. None of them. Where is Idaho one more time? 1, 2, 3, 4, 5. 4th lowest. This Idaho should not be the 4th. We have more median that are lower than Idaho. 1, 2, 3, 4. I guess that. So Idaho should not be the 4th. As the median of this remaining Washington, California, New Mexico, and Utah are probably more lower than Idaho median. Oh, that's tricky. A lot of stuff to read there. Oh, we are done with this chapter because starting chapter 2, scatter plots. We are definitely starting this part on the next live stream. So we've learned a lot today. Just majorly theory, no coding. Ooh, my head is worked out. Alright, so thanks for staying to the end of the live stream. If you found value in this video, do support the channel by hitting that subscribe button and giving this video a thumbs up. Let me know your thoughts in the comment section. And are you willing? Are you family? Of course. Are you excited to see me on the next live stream where we get to learn together? I believe, of course, you are. And we'll be continuing from where understanding data visualization. All right. Don't forget to check out the freelance client magnet course by my coach Benga DBE using the link in the YouTube description. And I'll see you on the next live stream or on the other video in the channel. Bye. Have a wonderful day.